Hi, welcome to our next level 2 probability video. In this video we're talking inverse normal. Inverse normal is where we're given a probability and we're going to work backwards to solve a problem. The problem was either going to be the mean, the standard deviation or an x value. And in this video we're going to cover 2 out of the 3 and you'll have to solve the third one in the same type of way. Right, example 1. In an Australian maths competition, the top 10% of students receive what's called a high distinction certificate. In the 2017 competition, the mean score was 52 and the standard deviation was 8, which means we're assuming that the competition was normally distributed, which it would be in real life. What score did somebody have to get to be awarded a high distinction? Here's our normal distribution curve with 52, our mean, in the middle. And here's our value of x, which represents the top 10% of students are above x. So when we say what score, we're trying to figure out x. What value of x, what score do we need to get where 10% of students are above? All right, to do that, hopefully you can figure out this region has to be 40%, because 40% plus 10% will make 50%, and half of the data is above the mean. Right, let's go to our table. Now, when we look at the table, we're looking at the 40%, not the 10%, because we're looking at the probability between the mean and an x value. So we're looking for 40%, and this is pretty close to 40%. This represents a z value of 1.28. So we know z is equal to 1.28. So we can get rid of the tables now, and we can go back and use this formula to solve for x. We know that z is equal to 1.28. We've just worked that out. We know the mean is 52 and the standard deviation is 8. And we just need to rearrange this equation to get x. So we're going to multiply both sides by 8. And we're going to add 52 to both sides. So to get x, we're going to go 1.28 times 8 plus the 52. And that gives us an x value of 62.24. Now that tells us any student who got a score greater than 62.24, maybe they got a score of 63, they are going to be in the top 10%. Now, in this exam, you need to show all this working. But what's great is once you do get an answer, you could use your graphics calculator and just quickly check to see if it does give you the right percentage of 10%. All right, let's move on to example 2. In an Australian maths competition, the bottom 20% of students received a participation certificate. In the 2018 competition, the mean score was again 52 and a participation certificate was given out for anybody who scored 40 or less. So we're going to work out what the standard deviation for the 2018 competition was. Well, again, it's normal distributed. So here's our normal distribution curve with 52, the mean, in the middle. And here is the score of 40. And we've colored in all the people that are less than 40 that get the certificate of participation. Right, well, this is 20% of people. So therefore, this region must be 30% of the people because 30 and 20 make 50%. So let's go to our tables and we're looking for 30%. Remember, we're looking for the probability between the mean and an x value. So we're looking for 30%. Now 30%, this is pretty close to 30%. And that represents a z value of 0.84. But we're going to make it negative because we are below the mean. So z is equal to negative 0.84. Remember, below the mean, we're negative z. Above the mean, we're positive z. Right, well, once again, we're going to use this formula again to solve for the standard deviation this time. So we know z is negative 0.84, and we know the mean was 52, and the x value, the score of 40. So we just got to rearrange this to get sigma now, the standard deviation. So let's multiply both sides by sigma, work out what 40 minus 52 is, which is negative 12, and divide both sides by negative 0.84 to get sigma of 14.29. Great.